What's going on, Algebros? It's Mr. C here, and in this video we're going to discuss the laws of exponents. Let's go ahead and get started. It says here if a is a real number and n is a positive integer, so something like 1, 2, 3, 4, and so on. We also allow for 0, by the way. Then the following expression represents the product of n factors of a. So here we have a with a superscript n. What this is basically asking us to do, or what it's equal to, is taking n copies of a and multiplying them all together. Now to do this generically, we have to use our imagination a little bit. We're going to write out one copy of a, use the multiplication dot there to another copy of a, another multiplication dot to another copy of a, this dot dot dot, ellipses symbol as they call it, and then one final a there. So this little part right here, the three dots consecutively, just means that we continue this multiplication by a until we have n copies of them. In other words, what we're looking at on the right hand side of the equal sign are n factors of a, the Fonz's favorite letter. But keep in mind, it does say factors, and factors are basically the items that are getting multiplied together. So basically this is repeated multiplication, and that's how you can imagine exponents, or that's basically what they're asking you to do. Now this expression right here, a with a superscript n, the a is called the base of the exponential expression, and n is called the exponent. No surprises there. But we also call it a power. Alright, and shout out to Darth Sidious from Star Wars, unlimited power. Okay, so now that we have this defined, let's go ahead and discuss some laws of exponents. And these are going to be helpful for when we need to simplify expressions involving the same base. Alright. So the first one is a to the power of 0. That's always going to be equal to 1. And later on in the course, I'll try to remember to show you why that is. We're going to go from left to right in this table. We have a to the negative n. What you can do here is write the expression at first being on top of 1. And to rewrite this so that the n becomes positive, we're going to switch the placement of these items. In other words, 1 is going to go on top, and then a is going to go on bottom, and we can go ahead and make the n positive. This is definitely a helpful one because a lot of instructions, whether it's in this class or a different class, ask that you write your final answer using positive exponents only. And so, if we have something like x to the negative 3, we could go ahead and apply this property, rewrite it as 1 over x cubed, and we will have satisfied one of the requirements of the instructions. It is possible to have negative powers in your denominator of a fraction, in which case, and looking at this one right here, we could go ahead and switch the role of numerator and denominator, where we have a to the positive n on top of 1, and that simplifies to simply a to the power of n. When you multiply two factors having the same base, what you can do is condense that into a single base, in this case a, provided you add the exponents together. Alright, so in other words, a to the m times a to the n, you add the exponents together, you get a to the m plus n. So if multiplication leads to addition, then you can probably see where this is headed. If you divide two items with the same base, in this case a to the m over a to the n, you write it as a single base a and subtract the exponents. Alright, so division leads to subtraction of exponents. If you already have something with a power but want to raise it to another power, in this case a to the m raised to the power of n, then you simply multiply the two powers together. So this is a to the m times n. Right, that's kind of like a power to a power property. If you have a product being raised to a power, then each factor in the product is going to get the power. So it kind of looks like the power of n gets distributed to each of these factors. So a to the n times b to the n. This is a little deceiving because, you know, if you have something like a plus b to the n or a minus b to the n, you might want to distribute the n to each of these, but that's actually an error. These are anti-properties, as I like to call them. A plus b to the n does not equal a to the n plus b to the n, nor does a minus b to the n equal a to the n minus b to the n. In other words, we cannot distribute the power across addition or subtraction. It only works if you have multiplication, and as we're going to see right now, division. So if you have a fraction being raised to a power, you can go ahead and distribute the exponent to the numerator, so a to the n, and also the denominator to get b to the n. This next one is pretty cool. You don't really see this a whole lot, but I do want to mention it nonetheless. If you have a fraction being raised to a negative power, and as I mentioned a couple minutes ago, some instructions ask you to write your answer so that all exponents are positive. We can actually rewrite this expression so that the n becomes positive, and the way to do that is to just flip the fraction. Let's write b over a instead, and that allows us to change the n to a positive n. And that, my friends, are all the laws of exponents, at least those that are going to be relevant for us in this course. Of course, if you have any questions for me about anything in this video, feel free to reach out. Otherwise, I'll see you in the next one. Thanks for watching.